recurrence relation of Hermite polynomial. Okay, today we discuss recurrence relation of Hermite polynomial. Okay, we know that Hn of x equals summation r equals 0 to n verg 2 minus 1 power r factorial n, okay, 2x power n minus twice r divided by r factorial into n minus twice r factorial. Okay, this is Hn x. Okay, then we get Hn of minus x equals what? Okay, r equals 0 to n verg 2 minus 1 power r factorial n 2x power, that is minus twice x hobe, minus twice x power n minus 2r divided by factorial r into n minus twice r factorial. Okay, then this minus 1 power r here minus 2, that is minus 1 into 2, we can write this. Okay, r is equal to 0 to n verg 2, okay, minus 1 power r into factorial n into minus 1 power minus, okay, n minus twice r, n minus twice r plus n minus twice r into, okay, 2x power n minus twice r divided by factorial r into n minus twice r factorial. Okay, then we can write that r is equal to 0 to n upon 2, n upon 2, that is minus 1 power r into factorial n minus 1 power n, we can write this minus 1 power n divided by minus 1 power twice r. Okay, and here r factorial n minus twice r factorial, okay, into 2x power n minus twice r. Then we can write here minus 1 power twice r is nothing but 1, and minus 1 power n, we can write here minus 1 power n r equals 0 to n upon 2 minus 1 power r factorial n 2x power n minus twice r divided by, okay, this is 1 into factorial r into n minus twice r factorial, that is equal to minus 1 power n into this is nothing but Hn of x. This is nothing but Hn of x, that is Hn of x. So we get Hn of minus x is equal to minus 1 power n Hn of x. This is my relation, first relation. Then we derive some recurrence relation, that is at first we derive Hn dash x minus 2n Hn minus 1x is equal to 0. Okay, at first we see what is Hn dash x. If we differentiate this with respect to x, we get Hn dash of x, Hn dash of x, therefore Hn dash x is equal to, okay, summation r equals 0 to n upon 2 minus 1 power r factorial n, okay, this is n minus twice r into 2x n power power n minus twice r minus 1 into 2x differentiate, that is 2 divided by factorial r into n minus twice r factorial. Okay, and we see that the generating function of Hermite polynomial, we know that the generating function of Hermite polynomial is e to the power 2 zx minus z squared is equal to n equals 0 to infinity h n of x z to the power n divided by factorial n. Okay, we know this. Then we differentiate this with respect to x to get this. Okay, differentiating this is equation 1. We take this differentiating equation 1 with respect to x, we get, okay, then we get, okay, e to the power 2 zx minus z squared. Okay, and if we differentiate of this e to the that is 2 zx minus z squared, that is we get 2z, okay, that is 0, equals summation n equals 1 to infinity h n dash of x z to the power, okay, that is n divided by factorial n, because we take this n equals 1 to infinity, because here we see that if we put this r is equal to 0 and if n equals 0, then we get 2 to the power x power minus 1. We define polynomial as the non-negative power of x, so this never be happened, that is n 2x power minus 1 cannot be taken. Okay, so we take n equals 1 to infinity. Okay, then we see that from equation 1, that is e to the power 2 zx minus z squared is equal to this is, okay, so we take this 2 into, okay, z e to the power 2 zx minus z squared is equal to nothing but, here that is n is equal to 0 to infinity h n of x z to the power n divided by factorial n equals n equals 1 to infinity h n dash of x z to the power n divided by factorial n. Then we see z power 1, we can write this as n equals 0 to infinity 2 into h n of x z power n plus 1 divided by factorial n, okay, equals summation n equals 0 to infinity 1 to infinity h n dash x z power n divided by factorial n. Okay, now okay, we take n equals n minus 1 because my okay equation is 2n minus 2n h n minus 1, so we take n, okay, okay, we take n for n minus 1, then we get n minus 1 equals 0, that is equal to n equals 1 to infinity, okay, 2 h n minus 1, okay, okay, n কে আমরা n minus 1 দ্বারা সাবস্টিটিউট করছি, that is, okay, that is z to the power n plus minus 1 plus 1, okay, divided by n minus 1 factorial, okay, equals summation n equals 1 to infinity h n dash x z to the power n divided by factorial n. Okay, equating z to the power n, we get, equating z to the power n, we get, equating the coefficient of the coefficient, okay, coefficient of z to the power n, we get here 2 n minus 1 of x, okay, divided by n minus 1 factorial, n minus 1 factorial is equal to Sn dash of x divided by n factorial. Okay, we know that n minus 1 factorial and n minus n factorial, that is n factorial, can be written as n into n minus 1 factorial. So this and that get cancelled. Okay, n factorial is equal to n into n minus 1 factorial. Then n minus 1 factorial and minus 1 factorial get cancelled. Then we can take, okay, Sn dash of x is equal to 2n, this is n, that side, 2n Sn minus 1 of x. This is the first recurrence relation. Okay, we see that Sn dash x minus 2n Sn of minus 1 Sn minus 1 of x is equal to 0. That is okay. Then we derive the second recurrence relation. Okay, the second recurrence relation is Sn double dash x is equal to 4n into n minus 1, okay, Sn minus 2 of x. Okay, okay, we know that e to the power 2zx minus z squared is equal to summation n equals 0 to infinity, okay, Sn of x z to the power n divided by factorial n. This is the generating function of a Hermite polynomial. We differentiate twice with respect to x, and then we get differentiating, okay, differentiating, okay, differentiating equation, that is 2, the equation 2 with respect to x for 2 times. Okay, then we get e to the power 2zx minus z squared into 2z is equal to summation n equals 1 to infinity Sn dash x z to the power n divided by factorial n. Here z to the power n is constant value because we differentiate this with respect to x. Okay, then again we differentiate this, that is e to the power 2zx minus z squared into 2z into, again we differentiate this, that is we get 2z, again we get 2z is equal to summation n equals 2 to infinity Sn dash x z to the power n divided by factorial n. Okay, factorial n. Then we see that e to the power 2zx minus z square is equal to this Sn of x z to the power n factorial n goes to 0 to infinity. Okay, we put this value in this. Okay, that is equal to, okay, n equals 0 to infinity Sn of x z to the power n divided by factorial n. This is nothing but 4z squared. This is nothing but 4z squared is equal to summation n equals 2 to infinity Sn, this is nothing but double dash Sn double dash x z to the power n divided by factorial n. Okay, then we can get this. Okay, if we multiply this, then we get 4 into summation n equals 0 to infinity Sn of x, okay, z to the power n plus 2 divided by factorial n is equal to n equals 2 to infinity Sn double dash x z to the power n divided by factorial n. If we put n equals n minus 2, then we get here the power z to the power n. Okay, we try this. That is 4 into n equals n minus 2 put, that is n equals 2 to infinity Sn of minus 2, okay, of x z to the power n minus 2 plus 2, that is nothing but n divided by n is replaced by n minus 2, that is n minus 2 factorial is equal to summation n equals 2 to infinity Sn double dash x z to the power n divided by factorial n. Then we get, if we equate z to, the coefficient of z to the power n, then we get, okay, equating the coefficient of z to the power n, we get, okay, equals 4 into Sn minus 2, okay, divided by n minus 2 factorial, okay, n minus 2 factorial is equal to Sn double dash of x divided by n factorial. Okay, we take n factorial as, okay, n into n minus 1 n minus 2 factorial. Okay, we can take this, that is n minus 2 factorial and n minus 2 factorial get cancelled, and we can get here, that is 4 into n minus 1 Sn minus 2, okay, is equal to is the double dash, okay, n of x, okay, this is the second relation. This is the second relation. Here we see that Sn double dash of x is equal to 4n into n minus 1 Sn minus 2 of x. Okay, now we try to solve the third recurrence relation, 2x Sn of x minus Sn plus 1 of x is equal to Sn dash x, or 2n into Sn minus 1 of x. Okay, we know that the generating function of Hermite polynomial is equal to e to the power 2zx minus z squared is equal to summation n goes to 0 to infinity, okay, n goes to 0 to infinity, then Sn of x, okay, z to the power n divided by factorial n. Okay, we know that. এখন we differentiate this with respect to z, because here we see that 2x. If we differentiate this with respect to z, we get 2x. Okay, in a term, then we differentiate with respect to z. Okay, then we get e to the power 2zx minus z squared into this is if we differentiate this 2 to the 2zx minus z squared, that is we get 2x minus 2z is equal to, okay, summation n goes to 0 to infinity hn of x z to the power n minus 1 into n, okay, n into z to the power n minus 1 divided by n factorial, okay, n factorial, okay. We see that e to the power 2zx minus z square is equal to hn of x z to the power n divided by factorial n, that is equal to, okay, summation n goes to 0 to infinity hn of x z to the power n divided by factorial n, okay, this is 2x minus 2z is equal to summation n goes to 0 to infinity, okay, here n, and this is n factorial, we can write this as n into hn of x z to the power n minus 1 divided by n factorial can be written as n into n minus 1 factorial. That এখন আমাদের লিমিট যাবে কত কিভাবে, n equals 0, if we put n is equal to 0, that is 0 minus 1 factorial, minus 1 factorial is infinity, that is we or undefined, that is undefined, we have to take n is equal to 1 to infinity, okay, then okay, we multiply this, that is n is equal to 0 to infinity hn of x z to the power n, here 2x, that is 2x into divided by n factorial minus, okay, n is equal to 0 to infinity hn of x z to the power 2z to the power n plus 1 hobe divided by factorial n is equal to summation n goes to 1 to infinity n get cancelled hn of x z to the power n minus 1 divided by n minus 1 factorial. Then we see that here n is n plus 1 and here is n minus 1. We try to make the power as z to the power n, so here z to the power n is already exist, okay, n is equal to 0 to infinity 2x hn of x z to the power n divided by factorial n. Here when how we get z to the power n power, if we put n is equal to if we substitute n is equal to n minus 1, then we get z to the power n power, that is n is equal to n minus 1 is equal to 0 to infinity 2hn minus 1 of x z to the power n divided by n minus 1 factorial. Then this right side is equal to how we can get z to the power n power, if we put n okay is equal to n is replaced by n is equal to n plus 1, that is n plus 1 is equal to 1 to infinity h n plus 1, n is replaced by n plus 1 of x z to the power n plus 1 of minus 1, that is n, okay, here n plus 1 minus 1 factorial, and this is get cancelled, okay. Then we can substitute this, okay, power z to the power n, coefficient of z to the power n, okay, we write a line, that is n is equal to 0 goes to n infinity 2x hn of x z to the power n divided by factorial n minus n is equal to 1 to infinity 2h n minus 1 of x z to the power n divided by n minus 1 factorial is equal to, here 1 get cancelled, is equal to n is equal to 0 to infinity h n plus 1 of x z to the power n divided by factorial n. Okay, we try to equate the coefficient of z to the power n. Then we get equating the coefficient of z to the power n. Then we get here 2x h n of x divided by factorial n minus here we get 2 h n minus 1 of x divided by n minus 1 factorial, and the right side we get h n plus 1 of x divided by factorial n. Okay, then if we multiplied the both side by n factorial, this get cancelled, that is 2x h n of x. Okay, this is n factorial, here n minus 1 factorial. We can write n factorial as n into n minus 1 factorial. There's n minus 1 factorial, there's n minus 1 factorial gets cancelled, and here only n remains, that is 2n h n minus 1 of x is equal to n h n plus 1 of x. This is the third required recurrence relation. Okay, we see that here 2x h n of x, okay, h n plus 1, that is h n plus 1, the right side. This, if we take this left side, we get here as 2x h n of x minus h n plus 1 of x is equal to 2n h n minus 1. Okay, we see that. And in the first recurrence relation, h n dash x is equal to 2n h n minus 1 of x. We can, this is x, replace that as h n dash of x. This is the third recurrence relation. Okay, thank you.